Hello guys, this is Han. So today I'm gonna do our help session, and my topic will be about object and function. So the topic for today is first I'm gonna talk about the basic of R, the object. Then I'm gonna talk about the function, which includes the building function, and we're gonna design our own function by simulating rolling the die. The last part is optional. If you really want to learn about R, I'm gonna give you some tips about how do you create your own function. I guess most of you guys have never had the programming experiences, so I would say this is definitely good for you. Alright, so let's first start about our object. So what is our object? Some people may say, okay, you can call object as variable, whatever you call it. Well, our object is a name, and we use a name to store the data. So suppose you have a name which is A, and you say A equals to 1. So you assign the value of 1 to A. Very straightforward, right? But think about the computer science way. A is actually a box, and 1 is a male, is a content, is a value. Alright, let's try a very simple example. Let's first assign A equals to 1, and then we will do A equals to A plus 1. And what's the value of A? Let me go ahead and do that in the R Studio. Alright, let's run that. Okay, on the bottom on the console, you can see that A equals to 2. Well, when you see that, let me go back to the slide. When you see that A equals to A plus 1, this is mathematical incorrect. But how is it correct in computer science? Well, so when the computer sees this line of code, what he does is he first executes the code on the right hand side. So it will first do the A plus 1. It will first get the letter of 1 and plus 1. So now the letter becomes 2. And then we'll put the letter back to the box, which is A. So now the A box contains 2 letters. So now that's how that works. This is seem like trivial, but this is very basic and fundamental concept of assigning a value. Alright, so now you know how to define a value, which is object. So then, there are a few things that you have to keep attention. So first of all, when you do the naming, you cannot start with number. And also, there's some special symbol which is prohibited, such as plus, minus, dollar, because this R itself has some meaning for that. For example, plus, it has the meaning of adding two numbers together. So these symbols are prohibited, so you cannot use that. And also, the name is case sensitive. So if you see that the capital name and the small letter name are different. So if you assign them with different numbers, they will have different numbers. Okay, the last thing is a very handy command. So if you define many variables, many objects, how do you know what their value is? So you can list all the object names by typing ls parentheses, and the table on the right hand side is a list of good names and bad names. So just keep in mind that you have some rules for the namings. This is pretty straightforward, and so I'm gonna try example. So let's define a die object, and what I ask you to do is you need to create a vector from 1 to 6, and then you have to assign the vector to object name as die. Okay, I'll give you 1 minute. Alright, I think you have done that. Let's see. So define a vector. There are several ways you can do. The first way is using C function. C, which is a list of element. You can start with C parentheses 1, 2, 3, 4, 5, and 6. That is very easy and simple. And then you can use sequence, which is SEQ, with just 3 inputs. The first one is 1, the second one is 6, and the last one is 1. So what's the meaning of that? This first argument means the lower boundary, which is 1, starting from 1. And the second one is the upper boundary. And the last one is incremental. Well, there are another short way to do that is 1 column 6, which is 1, 2, 3, 4, 5, and 6. Let's run this one. Alright, so they all give the same results. Alright, let's go back to the slides. So you all got, you define a vector from 1 to 6, and you assign to object named die. If you print out the die, it gives the 6 digits. Then we have to talk about the operations. So there are a lot of operations that we can do with a vector. I think you already know how to do the plus, minus. So let's try the multiplication. So if you type in die star die, which means the die times die, it's a kind of like element-wise operation. So you result will be a vector, and the element will be 1, 4, 9, 16, 25, 36. Well, this is equal to you define a vector of, you use a C function and you define a vector, and for each element will be 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. That's it. So that's element-wise multiplication. There are other multiplications such as inner multiplication and outer multiplication, and so go ahead and try that. I will give you 1 minute. Alright, I think you got it. So the inner multiplication is a vector multiplication. So the first vector will be a row vector, and the second one will be a column vector. So the results will be just a single value, because your row vector times the column vector will be just 1. And so that's the result. And the other multiplication is the other way around. So we start with a column vector, and then we times a row vector. So the results, well, instead of just one value, it will be a table, will be a 2D matrix. So go ahead and try that example and you will figure out how it works. So then we have covered the object, then we're gonna talk about the functions. So R has many built-in functions, for example, rounding, and the second one would be mean. So just go ahead and try the mean of die. I'm gonna show you in the RStudio. So the mean of the die is 3.1. Alright, this is pretty straightforward. Let's move on. So you can use the function separately, but you also can combine different functions together. And so let's define a function round parentheses inside the parentheses, mean parentheses inside the parentheses is a die, and the result is 4. So do you know how that works? Well, so when the computer do this code, it will start from the innermost and then gradually propagate to the outermost. So what it does is first it will do the die, because now die the vector from 1 to 6, and then we'll do the mean. The mean of 1 to 6 is 3.5, and then we do the rounding, and decimal is default is 0, so the result is 4. This is the traditional built-in function, so we're gonna try some fancy one. Let's try to simulate the rolling the die. We'll have to use the sample function. Well, the sample function has two arguments. The first argument is x and takes a vector, and second argument is the size and takes a number. So go ahead and try this example. Sample, set x equals to die and size equals to 3. So the results will be give you 3 random digits from 1 to 6. And then if you try the function again, it will give you a different result. So this is the traditional way how do we use the argument, and the argument order actually can be switched. So if you try sample size set to be 3, x set to be die, that works. So the argument order can be switched, and we can have a third way, which is a concise but less clear way, is we say, okay, sample, die, and 3. So if you ignore x equal, size equal, so the system knows that the first argument is the value for x, and second one is the value for size. But have to remember, they have to align the order of the arguments. If you try, say, sample 3 and die, that will give a wrong answer. So this rolling actually is a rolling without replacement. So what is replacement? So replacement is when you're rolling a die, you get a number and you put the number back, so that every time when you're rolling, you always have 6 digits in hand. But the default setting for the sample is without replacement. So if you try the first one, sample x equals to die and size equals to 6, you will end up with 6 digits and all of them are different. And what if you try the sample x equals to die and you set the size to be 7? Well, let me go ahead and try that. So if you set the size to be 6, yeah, you get all 6 digits. But if you try 7, well, you get an error message. The error says you cannot take a sample larger than the population when replacement equal to false. This is very interesting. So if we go ahead and check the help of the sample function, so this is the information I got. So the first two arguments are the required argument, and the third one and fourth one are the optional argument, and you see that they have been signed with the default value. So if you don't sign any replacement or the prop, they always be signed with false and none. So how do we change this to rolling with replacement? Well, we have to set the replacement equals to true, right? So let me try example. Define function rolling die 20 times with replacement. So the solution will be this. We set the replacement equal to true. And now from the constant, you can see that. So there are some repeating number there. So here we go. So that's the answer. And rolling with replacement. In the last homework, you're asking to calculate expectation of rolling a die. I guess most of you guys are using an analytical way, which is the expectation is the summation of each individual variable times their associated probabilities, right? So rolling a die, you have 6 numbers. They are all equal probability, so each of them will be 1 over 6, and you do 1 times 1 over 6 plus 2 times 1 over 6 and so on, and you loop through all the 6 and you get a value which is 3.5. So we can do actually another way, is not using the analytical solution. We can using our rolling die function. So we can roll in a die multiple times and calculate the mean. So let me just go ahead and roll in with 10 times and then I calculate the mean. So how do I do that? So I assign results which is equal to sample die size equals to 10 with replacement equal to true, and I calculate the mean. I put the result in the parentheses of mean. What's the result? Well, the result is 3.7. It is close, but not actually 3.5. How about like we try 100 times or even 10,000 times? I suppose the value will be closer. So let me try 10,000 times. Alright, so you can see that the value is very close to 3.5. And if I plot a histogram, well, every number has almost the same probabilities. Well, the y-axis is the frequency. Alright, so if we do the simulation in a large amount of time, they will have the same solution as the analytical solution. So, can we define a bias die? So previously, all the probability are equal, or 1/6. Let's try to define a bias die. And I say, okay, the number 1 will have a probability of 0.9, and number 2 will have a probability of 0.1, and the rest are 0. Now we have to use the force argument in the sample function. So we have to set the prob to be a vector, and to be a vector which is contain all these probabilities. So let me print the solution. So the previous 3 arguments are the same. Die size equal to 20 and replacement equal to 2. And the last one, the prob equals to a list of 6 from 0.9, 0.1, and 0. So if you go ahead and try that, you will see that most of the time only 1 appear, and you have some 2 appear, and you cannot see 3, 4, 5, 6. And then you can go ahead and try the expectation. Okay. So I'm gonna give you some tips about defining your own function, and this is optional. So if you're not feel comfortable about the previous lectures, just go ahead and just review that. And yeah, so if you feel comfortable, let's do this. So far I have defined the die function. We assign 1 to 6 to die, and then we call the function of the sample function, and we roll and die 1,000 times with replacement, and we calculate the mean of the result. I want to wrap the code, the 3 lines of code, into my own function, which is called roll. How do I do that? Well, before we talk about how do I do that, we first talk why we do that. Well, this is because when you wrap them in a roll function, that is very easier for you to reuse the code, because next time you only have to call the roll function instead of repeating write the 3 lines of code. Think about that. If you have a very long code, you have to repeat it multiple times. That just takes a lot of time, right? So what I would suggest is for you if you try to run a very large amount of code, so definitely you have to define the function. So this is the function constructor. So first come with the function name. You can define the function name to be roll. In the example, it is my underscore function. So you can sign with any function, just like any name for the object. Then will be an arrow sign. You can use equal sign, and then function, parentheses, and brace. So function, you should put function there. You cannot change any letter. And then this guy here, the parentheses, is where you put the argument, and the last one is where you put all the code. So, and in the last line of the brace, you can put the return, which is optional. Your function can return something or return nothing, but most of the time we need the function to do some operation and we want to see the result. So the return function will just return the value that we want to calculate. So let's go ahead and try the example. We want to define the row function and return the expectation. Here's how it works. So row, that's a function name, is assigned by the function, the parentheses, and the brace, and the 3 lines of code. And the last one is we return the expectation, and that's the right brace. All right. So I'm gonna head and use the RStudio to do this. First, you run this, and on the console you see didn't give you any result. It just repeated the code that I have written, because now you define the function but you didn't call them. The next line of code I will call that. Boom, it returned me a value. That's the expectation. Alright. So our argument. So previously in the parentheses there is no argument. We can set an argument. So instead of defining the die in the brace, we set the function parentheses with die. So every time you call the function, you have to assign a value for that argument. So let me go ahead and do that. So if I define the rolling one function and I call that without giving the argument a value, well, it gives me an error because it says the argument die is missing with no default. So the correct way is I assign the argument die with a value. Here we go. So that's the correct way to do that. So if you have a required argument, you always have to assign a value for them. Alright, to summarize that, so today we talk about our object and basic math operation, and we talk about the basic building function, and we try to do the rolling die function, and we learn about the required argument versus optional argument. And the last one is I'm talk a little bit about how do you define your own function. Thank you so much.